Folks, I wanted to provide a short refresher about Python and also point out some things, even if you're an experienced Python programmer, you might want to pay attention to in this class and also just in general with notebooks. Python is a wonderful language in some ways, but it has a couple of traps that I want you to be aware of. And so when I post this, I will make some comments about where you can look for specific things. But in any case, it's probably worth your thinking this through with me for 15 or 20 minutes. So this is the file from the website, and as I've said to you, I keep this open when I'm programming. I tend to keep it open, and some of the other ones, the Markdown tutorial or the LaTeX, because I can never remember everything, and you probably can't either. So think about keeping this open and referring to it. Okay. First thing you should always do, of course, when you open a notebook is to run all. And so you have it all available to you. You'll see that on the side here, there are code cells and there are markdown cells. And to run a cell, of course, you can highlight it and hit Control Return. You can also go up to here and say Run Cells. This is maybe not the place to go through so much of the details of notebooks, but I mostly want to talk about Python here. But the first cell, you can see the first one run and the second one that was run. This is going to have some imports. This is the place to put them, so we're going to use NumPy and matplotlib. Basic Python programming, you've had 111 or something equivalent, so I don't think I need to talk too much about that. But I do want to point out a couple of features of Python that you might not have seen or might not have been as familiar with. One is the idea of optional arguments. We're not going to use this too much, but this is something like what you can do in C and C++. If you don't know how many arguments there are, or if you want a variable number of arguments to a function, you can certainly do that. Here is my sum. It's going to just take the numbers and add them together. Here it has 6 arguments. Here it has 1 argument. Here it has no arguments. And what I can do is put a star at the beginning of the list of arguments. This is a single argument, which is going to be a list. You can see after I do this, I print out this, and there you go. It's a tuple, actually. I can find the length of it, and I just return if the length is greater than 0, I print out the last one. Otherwise, I take the sum. But the point of this is just that you can have a variable number of arguments. Okay, we may not use that too often. Here's a very important thing, however, that I use all the time. I find it so useful, which is default values. You'll see this in almost every assignment. Let's take a linear congruential hash. We'll talk a little bit about something similar to this next week when we talk about generating random numbers. But the point here is that I have an argument x, arguments, m, and b. Let's not worry about exactly what this does. It returns this formula. When you give the arguments in the argument list, in the definition, and you give them, you say a equals this. If you do not provide that argument, it will give it this value. It's a default value. There's no default value for x, but there are default values for all the others. Now, there's a little subtlety with this. Here you can see I've done all 4. 3 will be assigned to A, 7 will be assigned to M, and so on. Here I've only provided the first one. Here I've provided the first 2. Here I've provided. So you can provide it's another way of doing an optional number of arguments with default values for the ones you don't supply. It's a little different than the previous one. Now, one subtlety here is that If you're going to do this, you need to give all the values for some initial segment, for some initial list of the arguments. And at some point, you can go to giving values according to the name. But what you can't do is give a value for one of them explicitly and then assume it will figure out what the other one is. Don't do that. So the basic idea is you can give a list of values and it will line them up. But at some point, if you want to provide more values, and have it be assigned properly, you need to give the values. This is not going to, you need to give the names. So it does it by position first and then by name. So you'll play around with it, but basically you follow this model, it should be fine. List processing, you know how to do this. I mean, this is basic programming in Python, using slices. This says 1, 2, the end. This says everything up to 2. But remember that when you do this, the upper limit, the lower limit is inclusive, meaning it includes the value at 1. The upper limit is non-inclusive. In other words, it's the one before that. And this is consistent with the range function, right? When I say, let me just give you an example right here. When I say, if I want to print out a list, which is the range, say, from 1 to 6, I have to do it with the one after that, right? It goes from 1 to 6. This is the first one is inclusive. It includes that value. And the upper bound is non-inclusive. It does not, it's the one before it. So just remember that. This is consistent with C and Java and many other languages, right? So just remember that when you give an upper bound. So this is going to be 1 and 2, okay? 1 and 2. You can find the location of an element in a list. It'll do the first one. You can replace a value in a list. It'll go in and substitute it. You can use plus for append. You knew about that. You can add elements to the end of a list or the beginning of a list, or concatenate somewhere in the middle. Lots of things you can do. Now, one important thing we're going to talk about is the idea of the global memory. And I'm going to keep talking about, I'm going to mention this below, but let me give you one example of the problem. These cells are executed in order that you see here. If you say run all, it goes to the beginning and runs them all the way down. But if you start running things separately, here, it went all the way to the bottom and executed, and then I added something to show you an example. Now this is the 54th one to be executed. So here I have appended 2 lists, and I've generated a binding for C. Now all of these variables are stored in a global list somewhere while this is executing. A global list, very important. And it is updated dynamically. So this is because Python is an interpreted language. And you have a read eval print loop when you use Spider or some other idle or something else. And it keeps a dynamic list of when you made the assignment. This is very different than Java, where on the outline on the page, how it looks on the page tells you where the bindings are made. But this is a matter of the timing of it. So right now, if I go here above this, and I just say C, okay, it gives me this list. But watch what happens when I do this. Here I'm going to add an element to the end, okay, and I'm going to add something to the beginning, and then I'm going to put something in the middle. Fine. It used C, and it did that. But now C has been updated. Watch what happens if I go up here. C is different. because of the timing. This was 56. Sorry, I'm pointing at the screen. This was 56. This is 57. Watch what happens if I do this. It's taking the list and it's adding Well at the beginning and Snyder at the end and Paul in the middle. Right? Because C is updated dynamically. If I go back and do this, and do that, now I'm back to where I was. So you've got to remember that when you have a notebook like this, the variables are updated dynamically. And if you ever get confused, it's not a bad idea to go back and say run all, and it'll start all over and do it all over again. And now we're back, you know, now the number here is 68 because it's keeping track of how many cells it's run in the session. Now, if you ever get stuck, and I'm going to show you this more than once, if you ever get stuck or there's a problem or there's something weird happening, go to the kernel and say restart and run all. And you have to hit this. It will go and as if you started the session from the very beginning. Let's watch. Look at the numbers. Starts all over. That will wipe out the global memory and it will start it over again. Sometimes that's the solution to a weird problem. Okay, it got stuck. Oh, I put this in here and it didn't know what C was. Here I'm going to say run all below, and it's going to catch up. You can play around with these different options. Sorry. Okay, so just keep that in mind. Now, some important list processing functions, sorting. I can never remember whether it's b.sort but the standard one is sorted. Okay, to sort a list. Make a copy of a list. List is a constructor. So if you give it a list, it'll make another copy of it. You can do things like index. There's lots of different things you can do. Now, very important. There are a couple of methods that you can use, functions that you can use to permanently delete an element from a list. And I'm not even going to show you. DEL, it is. Try not to use those. In combination with this global list, it'll screw you up every time. Okay? It's better to make another copy of a list. Try not to modify the list in place. It'll just get you confused. Make a new version of the list by making a copy of it. Okay? It's in this class, it's never a problem. Okay, list comprehensions, we used them in the first assignment. Let's go through it again. One of the ways you can make a list comprehension, make a list, is to say, let's just go through the syntax of this. This multiply sign here in the standard list is take this list and duplicate it, concatenate it, and make a copy of 10 of them. If I printed out this list here, and by the way, get used to printing out intermediate copies of things. If you're trying to understand something, do this kind of exercise. Print it out and take a look at it. If it's too big, we'll try to do a slice, see what's going on. Print values out so you can see what's going on. You can see that it creates all zeros here. Then we go in and we put, for every one of the indices in here, we insert the square, of 1, 2, all the way up. Okay, that's one way of doing it. But, it takes a while to do that. You can do it all in one line with a list comprehension. And this is available in many languages like Haskell and OCaml and so forth. The for loop is here. And the value is here. And the way to read this is make a list of this expression for every k in this range. And it's exactly the same thing. So just stare at the combination of these, this and this. It's the same thing. This is a really nice way to create lists. I'm going to use it. I just got addicted to it. It's very common. You could put an arbitrary function in here. You do not need to use, any function, and it does not need to even include this k. Look, random doesn't include k. All this is doing is saying do this 10 times. Do random 10 times and collect them all together, right? So you can see I'm creating 10 random numbers between 0 and 1. You can also use multiple for loops, okay? You can use multiple for loops and you can use conditions. And I talked about this in the first homework. Let's review it again. Here is a double for loop. Here's the outer for loop. For each D in D and for each EL in L, concatenate these two and put it in the list. Watch what it does. The outer for loop says 0, 0, 0, 0, 0, and then right from here. And then it says 1, 1, 1 from here. And this is the inner for loop. So you can have multiple for loops. You can also have conditions. Here is a bunch of numbers, okay? For x in, x, for x in L3, if x is less than 63. So for x in L3, if it's less than 63, put it here and collect together. Look what happened, okay? Left is here. Right is for everything greater. So I've separated this list into two pieces, the ones that are less than some pivot and ones that are greater than or equal to. That enables you to do quick sort, pick a pivot value, separate them out into the left and the right, and then call them, quick sort in 5 lines. Very nice. Dictionaries are also a very important thing for you to learn how to use. I use them all the time. They're used in data science for one very important reason. They're incredibly efficient. They're based on hash tables. A list, where you have to go through and get to the nth item, that's not an efficient way to access information. A hash table is much faster. I'm not actually sure how they do it it might be faster in NumPy, but a dictionary is just a very efficient way to store information. You see that in this all the time in advanced programming. So here's a dictionary. The key can be anything, okay? And for each key, there's a value. So these are pairs. A is associated with 2, C is associated with 8, B is associated for 1. If you print it out, it just gives you the list. It uses curly braces. That's what indicates a dictionary. Empty dictionary, there's nothing in it. You can actually give this as a literal constant value, like a way of initializing it. And then to extract the value for a particular key, just put it in square braces, just like accessing a list. You can change the value by making an assignment. Look at this. Z, we added a value. If I were to say here, if I were to say A, it would simply change the value here. You can add a value. Let me put another one in here. You can add a value, or you can, or you can add new values. You can do sort of whatever you want with this. But you can see you can add values, you can change values. It's all good. You can use a value, get the value out, and then reassign it just like it's a normal variable. So what we've done here is take Z, okay. Now, here's a good example. This was run at step 64. This is from a previous version, right? So now if I want to do this, if I redo this, you'll see I updated this. It's not where it is on the page. It's when it got executed. Watch this. Just watch it. Just trust me. This will screw you up every time. You can look at the numbers, but it's better just to make sure that you think, if you're at all uncertain, go here and just say, run all below and just make sure it gets run, right? And then you can update it. So anyway, dictionaries are very, very useful, and just think about that. You can list out all the keys. They come out as this weird data, this sort of data structure, I usually do something like this. Remember, list will take arrays. This is actually an array with a label on it. And it'll make it into a list. So here's a list of all the keys. Here's a list of all the values. Lots of things you can do with keys, and you can read about that. Counter is what we're using in the first assignment. And this is a way of taking a list of outcomes, okay, and building a dictionary that tells you for the frequencies. It simply goes through every one of these and says, for 3, there's 5 occurrences. For 4, there's 5 occurrences. For 2, there's 2 occurrences. It builds a dictionary. And then you can go through all of the keys, okay, and you can list or, build basically a probability distribution or something like that. That's what we're doing in the first assignment. Okay. Features of Python to watch. I've already pretty much talked about this. So it's an interpreted language. So just make sure that you understand this, the dynamic sequence in which you've executed things, not the layout on the page. If you want to fix it, go up and run all, or restart the kernel, even better. It'll clear out the global memory and start it all over again fresh. Very good idea. Remember that trick. Python is a weakly typed language. It means that values have types, but variables don't. You can use a variable for any type. It'll screw you up sometimes. The global memory. The global memory. Remember that there's a global list which is maintained dynamically. I don't think I need to talk too much about this. I think you know pretty much that you can mix up types in a list, which some people like, some people don't. Just be aware of that. So what I want to show you here is just show you some problems that can occur with this dynamic memory. So here we have the function list. This is an unfortunate thing about Python. It lets you redefine basically any name. This will screw you up every time. Watch this. This is very simple, right? I've created this array and this list, and I'm just saying make a list out of this. Or I could have made this a tuple, which is kind of like a list and kind of not like a list. And it will make a list out of it, and it'll all work fine. So if you have a NumPy array, and you give it an array, and it creates a NumPy array, and if I print out, this is an array, it gets printed out with, we're going to talk about NumPy in detail at some point next week. It gets printed out without commas, because it's kind of like linear algebra notation. And here's a list with commas. You can take various things like tuples and everything and make them into a list. So list is the name of a function. Okay? Now, if I do the following, if I use list as the name of a variable, Python says, fine, shoot yourself in the foot. I don't care. Up to you. And it won't complain, which I think is a terrible, terrible thing. But I didn't design the language. They didn't ask me. So watch what happens. This all works fine. Okay? I've taken list. I've made a list. And then halfway through the cell, I redefined list. And now list is a list, not the function list. And watch what happens. I ran the cell again, and it caused an error. Why? Let's just think about what just happened. List was originally a function, which is a constructor for lists. And we saw that down here, just at list, oh, it's list. Then I redefined it to be a variable which holds a list. And then when I ran this again, it came through here and dynamically it looked this up and said, oh, that's a list of variables. It says list object is not callable. It's not a function. You can't call it, right? It's as if I did this. A equals 1, 2. And then I said A. You can't do that. It's not a function. So watch this. Do not use, and this is a problem, sum, list, square root. There's a bunch of function names. These are the most common ones. Sum. How often, I mean, do you think of writing sum equals 0 and using sum as a variable? Can't do it. Can't do it. Because now sum is not available as a function. So if you do this, the only way to solve this now is to go through and redo the kernel, restart. I guess you can remove it from the global memory, but I don't generally do that. So just restart the kernel. Oh, this got screwed up too. Oh, I think I used it here. Look, I used it. We have to redo it again. Okay. So just restart and run on. I'm not sure why this is screwed. Oh, because I did. Oh, because I left this in. Wait, where is it? Right here. I left it in. Look what happened. I left that in and it screwed up. So now I have to redo the whole thing. Right? Okay, now it'll work. I'm telling you folks, watch this, watch this, watch this. Anyway, now it's fine. And I already gave you some examples here. Again, just watch it because the typos will drive you crazy. So, you know, suppose you do x equals 1, 2, 3. Okay, you know, and now in memory, if I say x, right. Oh, sorry. Later on, there was an x that I reassigned. There's a good example. I didn't intend that. I used x later below, and it's down here somewhere, I bet. Yeah, look. Well, there's another one. I kept using x. Down here somewhere, there's an x. I didn't even think of it. Look, right there. There's an x. I didn't know that. I forgot all about that. I just illustrated to you one of the stupid things that you can do. Here, there's x. There it is. But if I go down here and run this one, 1, 2, 3, 4, and I come up here, it's 1, 2, 3, 4. If I come down here and run this one, and come up here and run this, if you're confused, you should be. This is not a good thing to do, right? So it's a global memory. Here's the problem. Here's the problem. You do this, and now you're fooling around and you're doing something else. And you create x1 or x something or other. And you're hurrying and you leave out the 1. What you meant to do was this. But you made a mistake and you did this. That, you know, even worse. Now you go down here and run this one. And now you do this. Where did that come from? Well, there's a typo, which is really hard to see, right? So, what's the answer here? I would try to use different names. You know, here's where I talk through. I mean, here I've, you know, if I could do this, and make global variables. These will now be put in the global list. If you don't want to deal with this, I talked with Mark Cravella about this, and we decided it may be the best thing to do. He's an experienced programmer. If you want, you can avoid the entire issue by simply putting all of your code into something where these are local variables. And so when you do this, you're not making any global bindings except for this. Another thing you can do, and I've sort of done this, this is the one I typically do. I try to name my variables. If this is problem 4, I say A4. There's no perfect solution, but you just saw what I did here and got all screwed up with this X, and it'll cause confusion. So try not to use the same variable names everywhere unless you're willing to constantly run from the beginning, and then just watch it, okay? The rest of this, folks, is basically what I did in the first assignment. But I would ask you to look down here and think about, it's all the same stuff, right? But I showed you how to, for example, make, the edges black here, and make sure that, the width is correct and so forth. But if you want, look down in this part, customizing your plots. The basic idea is that there's kind of like if you keep drawing, it'll keep choosing different colors, and it'll go through 10 different colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it starts over. Here's blue again, and there's this one again, and there's green. It'll go through 10 different colors. So as you draw things, it'll give you different colors. But you can change it, okay? If you want to plot something, you can say color equals, and you can either use R or red or G for green. K is black. You'd think it would be B, but that's blue. I don't know. So you can play around with this a little bit. You can also change. Here's an example of how you can draw different kinds of lines. So here are the different colors. Here's the line width, how thick it is. Here's the different marker. A dot, right, gives you these. O, for some reason, gives you this, and you can get different sizes. X, oh no, I'm sorry, well, maybe I got them all. But X, S is squares. This is a triangle. D is a diamond shape. So you can have different markers. These are all plots. Okay, I'm sorry, these are all scatter, right? And then lots of other cool stuff. And I would just keep this open. If you want to use it, just cut and paste, So you can put cool labels. You can actually use LaTeX. When we start to talk about LaTeX, you'll see that you can put $signs around something, and you can give really nice, well-formatted math. And you can put LaTeX in your titles. You can put labels. You can change labels so that they, instead of being sideways, let me give you an example here, you can make them right side up, which is nice. Doesn't work so well for a long phrase. You can put comments inside the graph. You can change the size of this. You can do all kinds of stuff. I wouldn't get too distracted with this, but I like to put a grid in it. So you can say you just do grid, and you can give the color. When the color is expressed as a float between 0 and 1, it's the intensity of the gray. Here is a gray background with white grids. You can go off and do this for change the font size of the labels. You can rotate them. Lots of different things. Anyway, I love this stuff. Don't feel the need to do it. I'm not going to require that you make things beautiful, but as long as you're doing it, make something that's attractive. Anyway, the main thing I want you to think about here is this business of the what to do if you get these weird bugs that have to do with with variable bindings. If you get a weird bug, this is my final statement, if you get a weird bug that makes no sense, go up here, restart and run all. It'll probably fix it. Okay, I'll end here.